Good afternoon, everyone, or good morning, depending on where you are in the world. I'm Paul Lavey from Swinburne Research at Swinburne University of Technology in Melbourne, Australia. Joining us for today's webinar, The Circular Economy, which is presented by the Manufacturing Futures Research Institute at Swinburne. You'll shortly hear from Associate Professor Boris Eisenbart, Program Leader for Design-Driven Manufacturing Innovation. But before I hand over to Boris, I would like to acknowledge the traditional owners of this land. I acknowledge that I'm hosting this webinar from the lands of the Dja Dja Wurrung people. I also acknowledge the traditional custodians of the various lands on which you all work today and the Aboriginal and Torres Strait Islander people participating in this webinar. I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters. We invite your comments and questions. Please look at the Q&A box on your screen. If you think of a question at any point, just type it in there and I'll pose it to our speakers. Alternatively, you may use the raise hand button and I will enable your microphone so you can verbally ask your question. And finally, this session is being recorded and may be published on our website and social media pages or those of our partners. If you don't want your voice to be included in the recording during the Q&A session, just please email me at the email address there. We'll distribute the recording to you all shortly after the session. At this point, I will hand over to Boris with today's presentation. Boris, over to you.
Oh, thank you very much, Paul, and welcome everyone. It's really gratifying to see the large number of people tuning in today. As Paul already mentioned, at the Manufacturing Futures Institute here at Swinburne, I'm a program leader for what we call digital design, but that also covers a lot in terms of, we're not just looking into direct applications of design for manufacturing, we're also looking at it from a more strategic point of view. So we're trying to span also business considerations and how they might impact on manufacturing and social realities, really. And at the moment, we might be, focusing on COVID more than anything else, and we are all affected, particularly here in Melbourne, in one way or another. But sustainability and the circular economy, particularly the requirements around becoming more sustainable, those challenges are not going away, and they're actually really huge. But at the same time, I believe Australia is perfectly set up in many ways for sustainable energy production, and to set themselves up to grasp the opportunities that arise from making that change to becoming more sustainable and enabling a circular economy. And that's also what is represented today in the speakers that we have. We've got Associate Professor Gavin Mellis from the School of Design, and he looks very much and spearheads a lot of initiatives in design for sustainability and circular economy. And that's followed by Dr. Stacey Konash, who spearheads a lot of the initiatives around digitalization and recycling in the manufacturing environment. So with that, it's a huge pleasure to welcome those two speakers. And today we'll hear first from Gavin. Gavin, off you go. Remember to unmute, Gavin.
Okay, now I'll just move this around. Good. So thank you, Boris. So look, we face unprecedented changes to our environment, economy and society, and for some, the circular economy promises to save the planet. So what is the circular economy? Where did this umbrella term come from? To what extent is this big claim viable? What are the opportunities and challenges for Australia as the states and federal government have announced CE elements in waste management policies and some funding to match? So I'm going to suggest that circular economy is a necessary but alone insufficient incentive to sustainable development, and that collaborations between universities, government and business and industry will be key to understanding and meeting the systemic transformations we face as a society. The project for an increasingly sustainable planet and Australia with growth decoupled from environmental damage is moving actually too slowly to avoid the inevitable 2+ degree warning that consensus suggests. So a slow global transformation towards renewable energy, and I've just taken a couple of pieces of data here from IEA's latest reports, show that our current dependence on coal, natural gas and oil dominates. We've got rising predicted GHG emissions beyond 2020, even given a COVID blip, and our increased overtaxing of the environment coming here from the footprint network. So all suggest that deep change is needed. The circular economy answer to save the planet is to aggregate a range of well-known strategies and approaches, including remanufacture, reuse, energy from waste for more efficient resource use and consumption, and close the loops. Popularized now by the Ellen MacArthur Foundation and partners including the World Economic Forum and MNC and other multinationals, the circular economy diagram, known as the butterfly diagram, starts by spreading the wings of the so-called linear economy, depicted as the central vertical flow from materials extraction and manufacturing to landfill at the bottom. In such a system, technical and biological nutrients or materials are retained in continuous feedback loops. The circular flow of these nutrients is represented by the loops on either side, green for biological and blue for technical nutrients. So this appealing formulation builds on 4 principles and 3 business processes, as shown left. It's worth emphasizing that despite the name, circular economy is not actually a new economics. It's not, by comparison with, say, environmental, ecological, or even neoclassical economics. It doesn't actually discuss how we deal with environmental deterioration. So it's this narrative and this picture which has been picked up by government in Australia, especially as an element of responding to our own waste management crisis and chaos. And it's been adopted with some enthusiasm by business and industry. As we'll see, turning that picture into a reality and measuring progress is more complex than drawing a picture. So where did these ideas come from? Circular economy is an umbrella term with many origins, and here I address some of these that are alluded to by circular economy itself. Umbrella terms in general are like most terms in the social and political sphere: sustainability, sustainable consumption, Janus-faced or double-faced, and can either bring people together, or if the fabric of the umbrella is weak, let the rain in. The term stretches arguably back to Kenneth Boulding's 1960s essay about a closed-loop economy, respecting ecological limits, where he contrasted our current cowboy economy of mainstream growth with a spaceman economy respecting environmental limits. And for more on this, my friend Rob Crocker at the Zero Waste Centre at UniSA has a great book which you can look at to read further on that. Then Pearson Turner's classic on environmental economics in the 90s developed a clearer and perhaps a more recognizable picture of a closed-loop industry-focused circular economy, still recognizing ecological limits, but monetizing externalities, that is, paying for pollution, finding optimal pollution abatement and through market policy and mechanisms. In China, it was this version of CE before the butterfly that was included in Chinese policy. Industrial ecology, meanwhile, is arguably the science of measuring flows, which is behind the business narrative, or should be behind the business narrative of circular economy, where resource flows are carefully calculated, loops measured through detailed life cycle assessment, for example. Industrial ecology is often symbolized by the Kalundborg industrial park in Denmark, where you have firms tightly linked together in a symbiosis, which is a key feature of IE. So that's sort of local networks as a basis for this. Finally, there's a number of other ecologically focused design-oriented models such as cradle-to-cradle biomimicry, which also coexist and have been brought under the circular economy umbrella. So some differences actually between what's the circular economy narrative and these models is that, one, there's a focus on ecological limits in these other pre-existing models. There's a careful calculation of environmental costs and benefits. There's this issue of industrial symbiosis, that is, local industry networks is important. And there's questions also about growth and consumption. So much for the theory. How well are we doing? So how are we doing? Well, globally not well. And this is due, I believe, to a narrow conception of change. Having lots of individual firm level cases, best cases, an overemphasis on just materials and recycling, and a lack of focus on the social, business and industry transformation including within policy, are problems with current discourses. Earlier this year, the third Circularity Group report 2020 found that the global economy is only 8.6% circular, and that's actually lower than in previous years. So we're going backwards. This means that over 90% of the resources that enter the economy, 100 billion tonnes per year, are wasted. So with all the policy, media and attention over the last decade, why are we moving so slowly? Look, reviewing about 200 or so of the most cited pieces recently about this, which I summarise for you here. Here is what the research and science is saying is the problem, if you like. There's a need for a more comprehensive working out of the details of this transformation. Number two, there are potential rebound effects within CE, which means that CE activities actually can lead to increased production and consumption. Three, there's a possibility that the concept is too vaguely defined to be of use. The fourth, that the speed of change to transformation is slow, and I'll show you the example of fashion in a moment. Five, there's a need for institutional changes and innovation. And six, there are questions about the measured regional impact, especially in China, that policy has had. One area where there's been a lot of individual initiative is in the fashion industry, with companies declaring themselves part of the circular change, Levi's, H&M, believe it or not, and thereby providing great individual cases. So while we must applaud individual initiatives in the sustainable fashion in this area, in this recent Forbes piece, current and expected growth in the fashion industry, as evidenced by this graph, is not going to be stopped by a few high-profile firms, since such niche experiments in sustainability transition are overwhelmed by market and consumption forces. So the key to change is taking CE at its word, I'm suggesting, and looking from a systems perspective at what is required behind end-of-pipe materials solutions. These are alluded to and illustrated in circular economy media, but not worked out in detail, and they need to be envisioned. So while from an individual perspective, there will be many reasons why you or I might want to play in the current circular economy innovation space, whether this leads to the promised transformation requires a deeper look at sustainability transition. While there is regular allusion to systems view in the circular economy, it's not clear that such an approach and its consequences is being adopted. Humans are driven by events and short-term horizons and find it difficult to conceive of system relationships. COVID, bushfires, and climate change are good examples, where lack of appreciation for system relationships and effects have failed to capture environment and economic interactions. In the following, I want to take you through 4 levels of system thinking consequences, if you like, from the sort of design through to business models, high-level system change, and detailed system dynamics look at the circular economy proposal. So to begin with, circular design strategies, speaking as I do, as Boris has also already alluded to, from within a program that focuses on design-driven innovation, offers one way of addressing the circular economy challenge at the product innovation phase. And there are strategies which we can adopt here and emphasize both in education and also in practice. Unsurprisingly, IDEO, the global design agency, has stepped up with Ellen MacArthur Foundation to provide a guide and education kit. So these design-driven strategies naturally need compatible business models and markets and working out how they're going to work. So on their own, they're not sufficient, but they are a start. So while we know that design innovation can sometimes drive uptake, whether this is sustainable and fits the circular economy brief of resource efficiencies is another story. So beyond design and materials innovation, which is very important and for which we have leading researchers at Swinburne, Professors Brooks and Ramdani, for example, we need new or business models. Or of course, we have examples of all of these CBM in Australia. That's not the problem. It's the degree of penetration of such models and their eventual market share, social acceptance, connection to sustainable supply chains, which we need to get from rhetoric and niche initiatives to change. This is where we currently are. So principles and processes are not difficult to visualize, but implementation will require social and industry change, policy and regulation. A little more complicated now and taken from a nice piece of work focused on the technical side of the butterfly, which I know Stacey's going to unpack for you a little more in the next talk. This high-level systems diagram shows, and focus especially on the vertical backbone from mining to landfill. It identifies opportunities in green and blue for value recapture, and also current challenges in the brown waste streams from components within the technical production system and supply chain system, retail and disposal chain. From an industry and research point of view, each stage and its associated ins and outflows needs close attention and offers potential for innovation. Just take the journey out of collection, for example, along this, at the right-hand side of that backbone. Typically to landfill with value loss, or potentially to incineration for energy from waste. Not actually ideal, but necessary as a transition. And then a particular pathway, R7, to acquisition and redistribution. This is revaluing of product, which is such as is enabled, for example, by Cam McKenzie when his Aspire platform for the better circulation of waste among companies as inputs. Or focus for a moment on component production with a normal pathway into end product and typical waste streams, albeit potentially reduced by implementing Industry 4, with return inflows from end product and derivative energy inputs possible with the blue dotted line. So this high-level systems view begins to flesh out the flows and processes in the butterfly in more tangible terms, both as opportunities and challenges. And we can begin to see the catalyst mechanisms that can make this happen. And this gets us closer to measuring and imagining the future, as well as identifying the need for the kinds of innovations we've just mentioned. Again, a reason why industry, government, and university research needs to work together to spell out beyond individual initiative and policy narrative how change happens. And finally, using one of my favorite tools in a nice paper by Franken and Shaw, systems dynamic modeling, which is an MIT innovation from the late 60s, late 50s, actually, Jay Forrester and co. We can get even more specific about the parameters, rates, inflows, and feedbacks for the relevant transitions. Just look at the left two subsystems in this diagram, product life cycle and demand distribution, where we've got potential for influence on market adoption. And the question then is how, what mechanisms? And as a result, potential influence and connection to green versus brown purchases, as influenced by image, by demand, by fear of functional failure. This is where recycled goods or materials are viewed as not as good as virgin stuff. So there's massive potential here when we properly map these things to address sustainability transitions and lots of opportunities. Any particular parameter could be unpacked further into detail, such as the collection rate for recycling, or as we discovered in one of my CRC LCL projects, the influence of media on decision-making and adoption rates in renovation. So again, I show you this for several reasons. One, to illustrate the necessary systems view of processes that's required. Two, to illustrate the necessary measuring of inflows, outflows, and feedbacks required, including for policy levers. And three, why collaboration between government, industry, and university is essential. So how's this playing out in Australia? So we've had multiple state and national policy statements, with perhaps South Australia again taking the initiative, and public discussion documents incorporating circular economy into waste management and recycling responses. Recent networks have set up and groups springing up to capture the momentum. So driven by our major waste management and recycling failures and our problem with bans progressive until 2024, although with exceptions, these have driven these existing policy innovations. These policies tend to reiterate the butterfly aspirational narrative about jobs, examples of other regions, and then give individual case examples. So it's aspirational narratives about the rainbow ahead. More importantly, perhaps at the moment, is the funding that's beginning to flow through to make this policy, to implement this policy. So the new Victorian Business Innovation Centre, just making this a little more concrete, and a current CRC round of priorities is looking at particular aspects of product recycle and reprocessing. That's the bottom 3 points on the left-hand side. Money is beginning to circulate, some focus on policy, and all of this is good, on policy implementation and addressing that and making that possible. The other thing, of course, that everyone does in this domain is to point to examples where we can learn from others. And one of those is Scotland, which is often brought up recently as an example. In fact, the details of the Scottish implementation, much of the media is still talking aspirationally about what could happen in Scotland. I just read this morning or last night, in fact, a recent public consultation 2020, plus also the local council's report in Scotland 2019, an audit report showing, in fact, that there have been very modest implementation of circular strategies. What does this mean for us? Of course, learn from others, but it means that Australia is going to have to make its own unique way in addressing this issue. So to get there, what are the kinds of barriers that we face to get over this issue of social acceptance of green product, willingness to pay, and other market transformations, and where there is still skepticism and unwillingness to fully accept recycle, reuse, and remanufactured goods as equivalent? Look, the current global literature is clear that at best there's varied and at worst low social acceptance across categories of products refurbished, reused, and so forth. So that needs to be addressed. 3 national surveys on attitudes to environment in Australia. This is WWF 2017, 2018. Shows, for example, over a 20-year trend, a nation less concerned about the environment and believing that concerns about the environment are exaggerated than 20 years ago. This, of course, may have changed with the post-bushfires, but also a CSIRO 2017 study, which I looked at, national attitudes to mining. Most of the nation is positive about mining and less concerned about its effects for transition. So that's good news for the current government. And then third, HP Australia's Planet Arc Survey 2018 showed despite high levels of concern about environmental issues, half or more of customer and business believe they're doing enough or they're neutral, so 30%, so that makes 80%. So we've got a social, economic and environmental disjunctive sorts that need shifting. That won't happen just through individual initiatives. CE is also supposed to be driven by widespread renewable energy. Yes, we are making progress in Australia, according to latest reports. Solar PV, of course, is doing really well. So is wind power to some extent, but it's slow relative to existing fossil fuel dependency. We're at best 24.8%. That was what I read on a recent counter from Melbourne Uni for renewables. So it's still 3/4 based on fossil fuels. We've got waste bans in place, but progressively put into practice till 2024. So slow change. Not enough for the ambitious innovation that is promised by CE. And so again, these are areas that we need to consider when we're looking at the reality of this change. Certainly widespread moves to renewable energy, such as through power purchasing agreements. I noticed Aldi, the supermarket chain, has bought into that recently. These are all positive signs, but the body of the movement needs to be much deeper and much more consistent. So we need deeper and faster shifts in energy and zero waste thinking. We need Industry 4. We need digital and 3D prototyping. We need new business models. And we really need, therefore, these collaborations that are at the heart of all this. Building low energy product longevity into a servitized and shared economy cannot be achieved, despite the current CE rhetoric to the contrary, without change and, yes, perhaps sacrifice. The Centennial Light is a pertinent link. A single bare light bulb helps illuminate part of the Livermore, Pleasanton Fire Department on the eastern edge of San Francisco Bay. The Centennial Light has been burning almost continuously since 1901. The proponents of a less resource-intensive, more circular economy, the bulb shows that everyday products can be affordable and built to last. Product longevity is purported servitized economy to meet growing consumption is one of the many challenges of the CE narrative. It's an old debate about embedded product obsolescence, but an obsolescence that's driven by market and industry demands. It's one of the many details that need concerted collaboration of business, industry, and academics. My argument is that unless we dig deeper together, the CE light will go out. So my personal pick, and something we're working on here at Swinburne, is how can we get industry players already invested in Industry 4, recycling, waste recovery, materials innovation, get them together with platforms such as Aspire's platform for sharing and revaluing, networking those businesses, and then together with university research on these bigger issues about their transformations for system level change. That's what we need to do. So thanks for listening.
Thanks, Gavin. We're now going to hand over to Stacey. And Gavin, if I can get you to just unshare your screen, that would be great.
Thanks.
Thanks. And Stacey. And just remember to unmute your microphone, Stacey.
Thank you, Paul. Thank you, Gavin. Thank you, everybody, for coming today to this presentation. Welcome. My name is Stacey Connish, and I'm a senior manager at the Factory of the Future. And today I'd like to discuss remanufacturing as a circular economy business activity, describe some of the challenges that the sector is facing, and suggest how Industry 4 can provide solutions. So Gavin explained to you in general where we are and the necessity for details. So I'm hoping to provide you some details, and maybe we can look at remanufacturing and see what we can do. So let's look at some of the business model that can contribute to decoupling of economic growth from resource consumption, which circular economy professes to do. So you've seen this map, and this is one of the way to visually describe the flow of material through the product lifecycle. Note that every activity in this map creates impact on the environment, and the waste streams are represented by this red or brown arrows. You can see the linear life cycle of the product in the middle, and blue lines are showing the flow of virgin material. Now, there is a hierarchy of how circular activities can retain the value of the product, also known as R hierarchy. Historically, the focus of governmental sustainability target and regulations were related to activities that work at finding better ways to utilize waste, such as recycling and energy recovery. However, recycling used components means that much of the energy and value that they embody is lost. So circular economy aims to move higher into R hierarchy to activities that are more effective in retaining value of the product and conserving resources. This focus, together with digitalization happening in society, gives rise to new consumer behavior, marketing campaigns, and business model. So I'd like to share some concrete example to illustrate this development. So let's look at refuse to consume. Supermarkets recently came under fire from consumers for plastic overuse. Some customer decided to not only refuse to participate in promotional campaigns like Whooshy Superhero at Woolworth, but also boycott this particular supermarket chain altogether. Another example of refusing the consumption is when the customer do not purchase individually wrapped products, like in this example from Coles. So both are examples of refusing to consume. Now, what about reduce the consumption? In 2015, Ray, an outdoor supply retailer, began a campaign that asked consumers to opt outside on Black Friday. Since then, every year on Black Friday, the company closes all its retail locations, including the website, and gives its employees the day off. In addition, it encourages consumers to join the movement by refraining from shopping and going outside instead. Over 1 million people and almost 200 other businesses pledged to join this campaign. So this approach is called demarketing and is used by brands to encourage anti-consumption. Another example of demarketing campaign is Don't Buy This Jacket from Patagonia. Although they ask you not to buy it, they actually do ask you to buy it, but buy fewer and more durable items. In addition, they do educate consumers as how much resources are used to create and deliver this product to them. Anti-consumption is a difficult option to sell, as part of our drive to consume comes from deeply rooted desire for status. Branded hashtags, similar to hashtag #optoutside, have the potential to provide status symbol without consuming a physical product. And this is the new opportunities that digitalization creates for circular economies. So if we move further into sharing economy, this is the approach that slows the resource loop by increasing the number of users per product. And you can achieve it by sharing the ownership of the product throughout its life cycle. One way of sharing is passing on the ownership by donating the unwanted goods to your neighbors. And this is the idea behind Give app. Give is a mobile app that lets you donate your stuff or find new free stuff posted by other users in your area. You can donate things or food. Another way of share the ownership is to lend you things temporarily. This is the idea behind Airbnb and Peerbot. This approach also decreases the necessity to purchase things so that you can use something that you only occasionally need, like tree cutting tools or a lawnmower. There is another approach, in an increasing number of ways to get access to things without owning them at all. For example, by borrowing communal things. And this is the idea behind libraries. Besides books, we now have toy libraries, tools libraries, and kitchenware libraries, where you can borrow power tools for that weekend project or cutlery and plates for big family get-together. These are all examples of sharing economy. Now, what happens if that appliance is broken or just not working properly? Well, you can return it to manufacturer or third-party repair, or you can repair it yourself. But let's see how repair and remanufacturing differs. So in repair, the user drops faulty product to a repair shop where only the faulty parts and components are fixed or exchanged. The product retains its serial number and manufacturer. The warranty on repairs is limited to the repaired components. And this is the way when the life of the current product is extended. In case of remanufacturing, much more rigorous process is occurring. The faulty product is pulled apart, all components are inspected for functionality and dimensions tolerances. Then the faulty and worn components are fixed or replaced and the product is put back together. The product is tested to ensure it performs as new or better. The product is then updated with most recent features and software. The design of the product may be changed to improve its performance. The product often is given a new serial number. It can be either returned to the user or put back into retail and sold to a different user. The warranty is given for the whole product and is the same as for the new product. This way, the new life cycle of the product begins without using all the materials required to manufacture the product originally. Obviously, not all products are suitable for remanufacturing. They could be too worn or too outdated. Now, refurbishment sits in between these two approaches, and it differs somewhat in the amount of regulatory oversight and extent of rework between different industries. So what can you remanufacture? Remanufacturing has been around since the 1930s, and it has grown to cover a wide range of products. Some of them are presented in this list. Here you can see some of the OEMs, which is original equipment manufacturers that have business arms and programs to remanufacture their product. For example, a Liebherr Reman program was launched in Australia during the challenges of the last mining downturn in 2014, when the global management team decided that the company would benefit from diversifying in Australia. So in addition to its original aim of protecting the company against cyclical nature of mining, the Reman facility provided two additional benefits. Firstly, it has helped the Australian mining customers to better manage their maintenance budgets by giving them alternatives, cheap alternatives to ordering new components. The second benefit was the benefit for the environment. For example, more than 1,500 tons of steel has been reclaimed through this program per annum since it's running. And here you can see some examples of third-party remanufacturers. So Davies Office is the largest independent remanufacturer of office furniture in the US, while Fluid Dry Holdings is a Melbourne company that provides remanufactured transmissions, and Injectronics in Hallam remanufactures a range of various automotive electronic components, such as engine and powertrain control modules, as well as several other auxiliary control modules. Remanufacturing is aggressively pursued in the most critical applications, such as airspace and defense. US Navy remanufactures precision antenna bearings for search, radar, and communication antennas. So why is manufacturing suitable for Australia? Well, due to complex, unique, and technical challenges, remanufacturing in Australia gives the chance for manufacturing industry restart. And it's especially suitable here because in the product lifecycle, our economy seems to skip several steps and goes directly from mining to the retail of the finished product. Or even recently, with the demise of brick and mortar retail, it goes directly to consumer. So this makes the broken product a valuable source of spare parts, which otherwise often have to be sourced from overseas. If the downtime costing you money, the ability to rework or exchange your product for a manufactured one suddenly becomes urgent and valuable. And that's what third-party manufacturers can do. All right, so what is the impact of remanufacturing? As you can see, it's super effective and decoupling consumption from materials use. It also supports quite a number of jobs in US alone, and these jobs are very technical and quite research driven because you need to do reverse engineering a bit. And obviously it has other advantages. So why is it not more widespread? Well, this fishbone was created by Rochester Institute of Technology in collaboration with 200 remanufacturing companies in US. As you can see, there are quite a lot of barriers, as with any business, and we won't be having time to go through all of them, but we can look at some of them in a bit more details. Some of them are quite unique for remanufacturing. So just to, first of all, to make clear, that remanufacturing is not possible without cores. And core is an industrial component that can be remanufactured. Now, what you define as core obviously will be different if you're looking at the TV or a train, but you have to have access to it to start the business. So what barriers can be connected to cores, say you do have access to them? Well, cores may not be available because the material scrap cost is too high, so they get recycled instead. The production is too low, the cores are too good, and so they have a long life cycle. Or they become obsolete before they can be remanufactured. Another way to look at it is that the cores are damaged or worn out. Another major obstacle to growth in the industry is a lack of awareness of remanufacturing and its benefit by dealers, consumers, and policymakers. So consumer perception that remanufactured products have a quality lower than original products limits the development of this sector. In addition, core knowledge is critical to enable the remanufacturing, and not all OEMs are open to share with third parties software and design for the cores. And again, this becomes an issue when they start threatening with patent infringement, charge licensing fee for software, claim the cores to themselves. Government policy that define used equipment and cores as waste do not help with importation or moving the cores across borders. So the workforce for this sort of activity obviously has to have quite advanced skills, because you need to be hands-on, but also in quite a few areas. And evolving technology, which evolves really fast recently, means that you have to be retraining all the time. In terms of technology, so one of the things that limits remanufacturing is the limitation in the material properties. So some material just get worn and you can't replace it. Okay, so how can Industry 4 help with that? Well, Industry 4 is the term that we use to describe the increased networking between different parts of the remanufacturing process. This network is enabled by cheaper and more capable sensors and increased processing capability at the edge or on the cloud. Technology and market for most products shift fast. This leads to manufacturers struggling to accomplish lean out of the processes and capture maximum value. The promise of connected and automated manufacturing processes is fast optimization turnaround time, as well as higher flexibility in product customization. Remanufacturing optimization is generally achieved at lower level than forward manufacturing because by its definition, it starts after the product is manufactured and used. So it doesn't have time to catch up. And also it has complexity of the products, variable inputs, every core is different, and customized requirements. These factors suggest that the remanufacturing industry is perfectly positioned to benefit from Industry 4, and it is expected that it would benefit to a larger extent than traditional manufacturing. So how exactly can Industry 4 help address the barriers? Well, these are some of the major enabling technologies that are associated with Industry 4. And in terms of cores and access to the data about them, wireless connection and smart sensors create smart assets with the ability to track the product beyond the retail and through the use cycle. This allows to catch cores before they are worn and locate them through tracking. The combination of data analytics and usage data becomes a foundation of digital twin of the product. And digital twin contains the data about the product design and functionality, which is required by third-party manufacturing operators. Another way to look at it is how will Industry 4 help with the worker and labor training? Augmented reality and artificial intelligence can support workers in decision-making and shorten training time. There is collaborative robots that can be moved around the factory to enable variations in the manufacturing process. In real-time, data-driven digital supply chain will decrease the cost of labor, transport, and energy. For technology, 3D printing and additive manufacturing can help with fixing worn material and replacing discontinued or custom parts. And the ability to create smart ecosystem where companies are connected through a product and applications and system integration creates new ways of collaborating for some companies that have never collaborated before. For example, you can have agricultural machine that has interface into farm management system with apps from insurance company, as well as weather tracking company. So they would never work with an agriculture machine manufacturer before on that level. Okay, so what opportunities for SUT or Swinburne University? What can we add to this? And how can we support Australian companies that work in remanufacturing? One way we could consider this roadmap that again was put together by Rochester Institute of Technology. And this is around the technologies that can enable certain steps in remanufacturing that are unique for remanufacturers. Okay, that's all from me. Thank you.
Thanks very much, Kevin and Stacey. We really enjoyed those two presentations, I must say, and lots of questions. I want to pick up on two things actually real quick before we jump into Q&A. That is particularly the clothing companies that Gavin mentioned. There was a study in 2012, I believe, on the London-based magazine called Tank, and I found quite an enormous number of cases where producing new clothes like t-shirts, shirts, whatever, was actually, from a production point of view, cheaper than washing a used shirt. And the cost is an extraordinary incentive, obviously, for a circular economy to work. But there's also an extra responsibility from policymakers to support that, because virgin materials are lost if we don't recover them, and that will become more and more pressing. And the final thing I want to pick up on, and then let's go right into the Q&A thing, is actually another thing that both speakers touched upon is, there's this notion of trying to save the planet from exploitation. There was an Australian comedian who turned this around, because for some reason people do not really react to that very emotively by saying, oh, we need to save the planet. People get overwhelmed with that oftentimes. But he turned it around saying, you know what, the planet doesn't give a damn about the human race at all. And it'll be happy when we're gone. It is us, the humans, who have to maintain we need to become more sustainable in order to maintain ourselves on this planet. So a couple of points there. Maybe it makes you chuckle a bit, but yeah, there's a fair point here. I already saw a few questions pop up for Gavin and Stacey, so let's jump right into that.
Great, thanks, Boris. Okay, so we've got a question from Jasper. Question for Gavin. In the transition to C, how important is international and local open sharing of knowledge, best practice and expertise between industry verticals and knowledge sectors? And what is the importance of government policy to facilitate this process? Or are there framework suggestions to achieve this?
Yeah, so good comment, good question, Jasper. Of course, international sharing is important because it's one of the avenues for looking at best cases and what can happen. So comparing ourselves to a leader like Netherlands or even to Scotland and facilitating that exchange. I think that's happening anyway in different kinds of networks that already exist. So I think that's already happening. Government policy to facilitate this, well, to some extent, some of the funding through CRC, ARC, or other kinds of funding mechanisms would be a way of facilitating that process. If there was some way of also seeing how this could directly influence the speed of change. So, I mean, that would be my just first immediate reaction to that.
Thanks, Gavin. Another question for you from Jane. Gavin, does the need to return to the 1950s system diagram for 60 to 70 years ago mean that digitalization, including internet, all the smart logistics, barcodes, RFID, Internet of Things, advanced logistics, miniaturization and lightweighting have had no fundamental impact on flows, cycles and paradigms of movements of goods and services, human consumption and waste production and reuse over this period? Is BAU, i.e. BAU has been in no way disrupted and circular economy has not been facilitated?
So good question, Jane, thanks for that. No, so system dynamics modeling is actually a very actual it was based on some work by Jay Forrester in the 50s in MIT, but you could have a look, for example, at Eric Preutz's work from Delft at the Pease Center, or MIT's work in Sloan School. System dynamic modeling, including through participatory formats, is a way of overcoming policy resistance. It's being used by governments and sectors and within industry to try and map the actual processes and parameters that stand in the way of progress, and to identify policy levers and how to make change. So my reference to it was really more to do with the way that policy should interface and should consider systemic processes. And of course, as you say, many of those mechanisms that you mentioned, RFID, Internet of Things, barcodes, Industry 4 in itself, these mechanisms have had or at least potentially could have had a significant impact on the sustainability of consumption and production. But the reports on our progress with circularity or sustainability show that they're not having the kind of impact that they purportedly could have. So yes, indeed, I mean, business as usual could have been disrupted in a deep and significant way towards sustainability. There's no clear evidence that that's happened. So again, the ambition and necessary change is going to need to be deeper and more fundamental.
Great, thanks, Gavin. We have a question from Mohsin. I'm going to enable his audio so he can ask the question.
Okay, so can you hear me now?
Yes.
Yeah, thank you very much. Very informative session, and I'm so glad that I was able to find people who have done such great work on circular economy here in Swindon. So I come from the Faculty of Business and Law. I research circular economy in the context of sustainable supply chains. So all the things that have been mentioned, I've read through those things and I'm fully in support of what has been mentioned. One thing that Gavin mentioned was also very important, and I particularly focus on that, is that, as Kevin mentioned, that the circular business models have been in place in Melbourne and in Australia for many businesses. However, the challenge is the scalability of those circular business model. For example, one particular thing is, there was a business who using the cartridges and the ink cartridges and computer cartridges for making a road that was stronger than the normal road surface. Now, that all good on an experimental basis, but in order to have that thing really scalable, so that the waste from one particular supply chain goes on to become the input to another supply chain. So that sort of thing is missing. So there are isolated incidents where on a trial basis, these things would get connected, but scalability is the missing element. So my question to Gavin is that, and also to Stacey, is that despite the promises, why there is, what are the factors that are stopping this large-scale implementation of these innovative ideas for circular economy? Thank you.
Maybe I'll just say something briefly and I'll let Stacey give her. I think what I mentioned in my talk is that one of the two problems. One is the nature of, even if you look at the current policy elements in waste management strategies in Australia, and even the funding, they continue to focus on narrow kind of materials innovation. If you keep doing that, you're going to keep coming up with niche experiments. But unless you have business models and a broader systemic thinking about change, it's not going to happen. And we see that everywhere. That's a common story across the circular economy narrative. So it's a question of how you frame this as a systemic issue, or as a chance over the next few years to have a few more best cases. Consumption will overwhelm individual experimentation.
Okay, well, thank you for the question, and thank you, Gavin, for answering. I just can add that in my experience, there's two things. One, government needs to enable more business opportunities and either relax or enforce certain policies, for example, of necessity for recycled material in certain products or something like that. So a lot of industries in Australia are very closed for newcomers and for new technologies. And another thing is that consumers need to bond together and lobby the government to, move in this direction, and also demand certain products with certain properties. So, for example, for remanufacturing, if you don't walk into the dealership and demand the remanufactured car, because you just don't think that's appropriate. But if it should be the case, you should be able to go somewhere and ask for a manufactured product, which is normally half the price. So this is not happening, and we hope to increase this awareness in consumers and the government. Yeah, lost opportunity.
Thanks, Stacey. Boris, did you have any comments?
No, I fully agree, particularly with what Stacey said, and Gavin for that matter. We need more systemic thinking, to pick up on Gavin's comment, and there is so much lost opportunity here, really, and Stacey's absolutely right to point that out. There are so many products where the core, as Stacey said in her talk, can perfectly be reused. The customer will never see it because it's in fact the core, it's the platform, and anything around it can be made, nice and shiny and new. But a large percentage of things can be reused, but it's not done at the moment. And yes, maybe digitalization and connection between industries will enable that. So that's our hope, and also questions that we ask in terms of Industry 4.0 at the moment, very much.
Thanks, Boris. Thanks, Mohsin. Now, a question from Sally. Hi, Sally. Welcome. Stacey, are there any networks for companies interested in or already working in remanufacturing in Australia at the moment? Are there many companies already working in the space for, say, mining?
Yeah, thank you very much for the question, Sally. Yes, so automotive aftermarket is one of the major remanufacturing sectors in Australia, and cartridges for printers are another sector. I'm really keen on getting into medical devices remanufacturing. I think it's such a lost opportunity because all other countries are doing it, and yeah, we are missing out. And I think our patients are missing out on the best possible, money that can buy sort of equipment. So yeah, I think we should expand that. That's the point that I'm trying to make.
I have a question from Corey just asking about what industry bodies in Australia are connecting the Industry 4.0 organisations and who will drive the shift to CE?
Good question. I think we're gonna see how it turns out. Everybody's trying to drive it. It's just, yeah.
There are local initiatives in Victoria at the moment very much to stipulate sustainability and sustainable projects. So we see things happening in that space. And as I said, starting with the webinar today, we see countries embarking on that journey and creating extraordinary opportunity through that. But it does take quite proactive governmental incentives, or it has needed that in those countries. And most of them tend to come from Europe. And as Gavin rightly pointed out, the Netherlands is one of those spearheaders. There's a lot we can learn from that, but I think we should actually take the opportunity up and try to surpass them in Australia, because there is so much opportunity. And at the moment, everything is sort of tuned down. Maybe, and we're all looking what could be the next thing. What is the economy past COVID going to look like? Maybe this is the momentum, or this is the point in time to pick up that momentum and make things work. I would love to see that.
Thanks, Boris. We have lots of questions, but we're near the end, but we've probably got time for one more question from Stephen. I'm going to enable his microphone so he can ask his question. Stephen, are you there? And your microphone is muted.
Hey, can you hear me?
Yes, I can.
Yeah, look, thanks very much for the opportunity. It's more of a comment rather than a question. Yeah, look, I represent the Pack Group. We're a major packaging company in Australia and New Zealand and throughout Southeast Asia. I guess coming from industry, the perspective of industry, some of the things that we need to focus on, obviously, to make this work is, firstly, there was a big part of this is having the legislative frameworks in place to be able to support a circular economy. That's key. But one of the other important aspects as well is improving source separation or putting investment into the right infrastructure to be able to get access to separate streams of recycled materials. I think that's important, particularly, I guess, in the plastics industry, from a food contact perspective. The other thing as well is I think we need to be focusing on upcycling and not downcycling. And the reason I say that is just to use an example of, particularly with some work that's going on around plastics into roads. From my perspective, I don't believe that is a truly circular solution, because all you're doing there is you basically stop it from going to landfill. You're actually putting it into roads. It's not a true circular solution. And I think plastics in roads there's still quite a lot of variables around it. It's something that needs to be fully and properly investigated, particularly around, especially in Australia, how we've got such differences in temperature around the country. it's also you don't want to be contributing to proliferation of microplastics, and also the recyclability of the asphalt after several years of use. So still something to consider as an example of the circular economy. So yeah, that's just some perspective from myself. Thank you.
Thanks, Stephen.
Can I just pick up on that great comment here from Stephen? I think there's three related things we can point to here. One is that the current policy, as I mentioned, in Australia has been framed very much in terms of waste management and recycling. That's a bit unfortunate, necessary but unfortunate, because it looks at the end of pipe type solutions, and what we actually need is far further up the chain to begin this process, which relates to what you're saying. Secondly, a bit like most other sort of climate mitigation strategies, there is a transitional phase where you need to come up with ways of dealing with the mess you currently have, and so they're never ideal. So sure, that is important, but at bottom, what you're saying, and I think what everybody is saying, is for a real sustainable circular economy, we need to be beginning this process way up the supply chain, way up the design chain, because otherwise we're kidding ourselves.
Thanks, Gavin. Okay, I think that's pretty much all the time we have now. So thank you everyone for joining us. We had a great turnout, and thanks for the questions. I'm sorry we didn't get to all of the questions. Thank you, Stacey, Gavin, and Boris. Look, if you have any questions, feel free to shoot us an email at mfi@swinburne.edu.au. Definitely check out the Manufacturing Futures website and see all the fantastic work that's going on. Stay tuned, we'll keep you in the loop for any upcoming webinars, and we look forward to seeing you next time. So thank you. Thank you.